Hello Professor, this is Alberto Martinez with the demo for Lab 4. So to start off with the initialization, we're using UART 0 because that is the one that is able to communicate between the keyboard and the microcontroller. And we're using port A and waiting for that data to be put in. And disabling the UART and setting the baud rate to 115,200 with 8-bit word length, with no parity bits, 1 stop bit, and 5 posts activated in here. And then we're enabling the UART and setting alternate and digital functions enabled in order to use it. And we're also disabling analog functionality because that doesn't apply. In here, we're just making sure that PCTL is set for port A1 and port A2. The inchar is the function that is able to take the input from the keyboard, so it will take a 1-character bit and it will wait for it to be 1 to know that it has the stuff, it has the data allocated to be sent in. Outchar is a function that is going to output data from our code into the serial communication in order to give a result for the data that was inputted. And outstring uses outchar and just loops through it so that we're able to use more than 1 character, so it's able to use a whole sentence. Back to our main, we are using, these are the waves, sine wave, triangle, square waves that are lookup tables created with 256 characters in order to cycle the 8 bits of data that we're trying to use and show the output, the wave necessary for our purposes. Index is just the variable that is going to cycle through that lookup table. DAC in is setting up the bits that will take the data out into the from the microcontroller out into our 8-bit DAC, and that is going to be port B7 through 0. DAC out is where we're taking that port B data and taking it out, and this up here was just the initialization of it. We also have the 6-tick timer, which will able and get pitch here. This tick timer just initializes the timer settings, and this is function down here, get pitch, sets the reload speed for the SysTick timer. So every single time we tell it to go, it's going to be able to help change the frequency. And then in our SysTick handler here, this is where I am putting the waves, and they're being indexed through into the DAC out, which again is what is going to take that data and transform it into waves. This I is just for testing purposes for the debugger in order to be able to see them on my computer. And the way this is going to run is we initialize everything, and then the very first time I made it so that it doesn't take any input. That way the very first thing that you're going to see is always going to be a sawtooth wave. Then from there, depending on the inchar for the UART, you're going to take, if it's a T, it's going to take the T and then go back up here and output the triangle wave. And it does so similarly if it's an S, it'll output a sine wave. Here it'll output a square wave. And it will also give out a message into the serial communication, so PuTTY, and it will set the frequency of it. And then only for the first time it will show the sawtooth, and then it will set reset to 0, and then it will take the end characters. So for the demo here, I have PuTTY, and you see that it says it's running lab 4, enter to UART, and automatically displaying a sawtooth wave. So here you see if I click Q, it's going to display a square wave, and it gives us the message that it's doing it. If I click T, it's going to be a triangle wave. And then if I click it's R, it's going to be a sawtooth wave. And if I click S, it's going to be a sine wave. So in order to display, I used the line function generator that Kala has. I have a couple pictures that I'm going to be sending, but just to show you a little bit, because I'm having a little bit of trouble with the oscilloscope, here is the square wave that was generated at the frequency 262, which is going to be the part for project 1. But yeah, everything seems to be working, and I'll send those pictures to you. You have a great day, Professor.